we discussed an equation and exercise for streamline by using one method, and now we will try to find the solution by using another method, an alternate method, but which should produce an equivalent answer or the same answer exactly. So that is why this is shown here as method B, and we write down the equations of streamline as dx by u equals dy by v equals ds, and from this the value of dx is equal to, as shown, and when we integrate them both sides, then x will be integrated from 0 to x, and s will be integrated from 0 to s. And the integration is shown to you as you can see in equation 1 and 2, and from equation 2 we see that y, the integral y, is equal to v naught is a constant, so this will be v naught into s, and since this is a definite integral, there is no constant appearing where we get exactly this value. So y is equal to v naught into s. X is therefore equal to, making the appropriate substitution. Here there was y, and we write for y the value of y, which is v naught s. This reduced to, you can see, v naught divides another v naught constant, so they cancel, they neutralize each other, and we are left with integral from 0 to s u naught into sine of omega t minus omega s into ds. Now this term is written as this, and you can see the term ds has disappeared and everything has been converted into theta. There is no s now, and we are only now talking about the time t and also in terms of theta. Omega is some constant. How do we obtain ds equal to this value is shown here. Theta is equal to wt omega t minus omega s, and therefore if we differentiate the two, we obtain d theta equals, this is a constant quantity, minus w, which is constant, into s, the derivative of s will be ds, and from these two ds is equal to minus 1 over omega goes on this side times d theta, which we write as this, and this has reduced, so we change the value of ds and we write instead minus 1 by omega times d theta, and we obtain this value. And you can see that it looks like a very simple, sweetly placed form in which it is very easy to integrate it. And then integrating, this is equal to the integral of sine theta is cos theta with the negative sign, and we obtain here u naught over omega t into cos theta between the two values that are associated with the lower limit and upper limit of the integral. When we substitute these values, u naught divided by omega times cosine of omega t minus ws for the upper limit and minus this quantity for the lower limit. When t is 0, we obtain the value of x naught equal to as this, just by writing t equal to 0. And when t is equal to pi over 2 omega, we obtain the value of x as this. So therefore, this you will see is the same value that we obtained earlier. So we calculated the same value of u by alternative methods, still rendering the answer the same.